Okay, we'll make a start now. Good afternoon, everyone, and welcome to the July edition of the CEPREC webinar. So, CEPREC is the Secular Economy Powered Renewable Energy Center, and we're a Pan-Africa research center dedicated to advancing Africa's energy transition by leveraging the principles of circular economy. And today in our webinar, we are privileged to have one of ours, Professor Barry Ron, who leads activities in Rwanda. And he's a professor at the Carnegie Mellon University in Rwanda. He has interest in studying centralized electricity infrastructure, and more importantly, for this project, he's been contributing to innovation in the circular economy of energy storage by the study of battery repurposing and battery pack design and control. And so today we are very excited to have him here to present from his wealth of expertise on this important topic. So I will hand over to Barry now. Please, you can feel free to type your questions, and you can also we'll have a session for Q&A at the end. Over to you, Barry.
Thanks very much, Muiwa, for your introduction, and it's great to be with everyone here at CEPREC. Like Muiwa mentioned, I've had the opportunity to be in this space, looking at some of the technical side, some of the data statistical side, and we have a great team in Kigali supporting us and looking at how this waste stream actually could be useful for energy access, actually lowering the levelized cost of energy for mini grids. So if I just sort of take you through this, what we're going to try to do is talk a bit about the objective of the work package, give some context, talk a little bit about the second life potential that EV batteries have, and we'll get a little bit into the range of batteries that we can expect. It's not easy when you're repurposing waste. We'll talk about some possible circular business models and some use cases, and then we can have a conclusion and get to some of your questions. I think we can jump right into it. I'll keep an eye on the chat, and if it seems like I can answer that question in the stream of the presentation, I will. So, as you may have seen, CEPREC is a consortium that actually stretches across two core pieces. We're looking at essentially the pieces of microgrid power. How do we actually put together that system? How is that thing going to be managed? But then the other side, how can we think about a circular economy feeding into this? So there's also a cross-cutting work package on impact and policy. So that's CEPREC. The Kigali Collaborative Research Centre is a nonprofit organization registered in Kigali that wants to encourage collaboration across East Africa, across Africa in research and innovation. So we have a wide range actually of projects ranging from data science to agriculture to energy. That's kind of the context here. If we think about what challenge we're solving here, we still remain with a huge fraction of people, especially in sub-Saharan Africa, who don't have what we call reliable electricity. You can have a grid connection, but it can be quite unstable. And so this is where battery storage actually is already a hot selling product, even if you're grid connected. But then there's a question of people who are rural. They may have a low socioeconomic status. We may start giving them energy access with solar home systems, but often actually reaching them with the grid is unreliable. So when we look at sub-Saharan Africa, it's one of the most challenging spots for energy access. It's got maybe a fifth of the world's population, very young demographic. Electricity is still relatively low, even just on a national basis, on a per capita basis. But we do have a massive advantage in the form of our solar resource. So if we think about how we're going to do this, the challenge is that before you can even put a mini grid in a rural area, we have to recognize that most mini grids, although they may be the cheapest way to bring high tier, high quality electricity access to a village, um, the cost may still well beyond what can recover. Most mini grids are subsidized. They don't manage to cost recover. Maybe they can cost recover their operations, but there's a range. It's very challenging. So when we think about energy access, we're seeing mini grids appear. Initially, it's been kind of an experiment. Uh, the growth is projected to kind of continue. And in fact, one of these mini grids may end up merging with the main grid. So their cost is high because they need to be to a certain standard, uh, which is looking forward. But when we think about that actual levelized cost of energy, the energy storage is a core component of it. So if you look at many parts of Africa right now, uh, it can be that, like I was saying, grid extension is way too expensive compared to actually building a mini grid. But if we think about the battery component, the lithium ion battery component, which is the now kind of the most common chemistry that's used even in mini grids, the cost range tends to be up between kind of 50 to 75 USD per kilowatt hour. It can get lower down to like 30, 40. But what is kind of really interesting is that if we put the work into repurposing cells from different sources, could be EV, could be laptops, could be maybe even cell phones, although that's very challenging. Um, what we see is that the LCOE can actually start to approach that of lead acid. So in a system where you're aggressively trying to minimize the battery capacity, uh, it's a huge advantage if we can, number one, solve the waste problem, and number two, have that component of the costs lower. So it's really important. Uh, where we've started to now see a synergy is if we think about electric vehicles, they are really starting to spread. But what's interesting is in East Africa and West Africa, the presence of two-wheel electric transport is actually growing really fast. It's growing faster than what we see in other parts of the world. So you can see here the breakdown. China has always been the leader in this. What we see actually incidentally in China is that in their telecom towers, they've switched from using lead acid in some cases to using repurposed lithium ion batteries because they have such a strong battery industry in China. So if you look at this graph, you can see kind of that exponential rise in EV deployment. Clearly, China is the world's manufacturer of EVs. Despite Tesla, they have an amazing market share and a lot of innovation in China. So what we can expect is that at first, the 2 and 3 wheel vehicles that are electric are just immediately making sense because they are Africa's fleet vehicle. In some parts of the world, you have taxis. The taxis became hybrid because of operating costs. In Africa, it's the same thing. The petrol motors are turning into EVs because the operating cost tends to be maybe 30% lower, 50% lower. Huge, huge difference. So in both Rwanda and Kenya, we see a lot of adoption. These are jurisdictions that have even supportive policies, public-private partnerships, tax exemptions. In Rwanda, there's an import incentive. So what we can expect is that because of these incentives and because of the advantage with costs, and also incidentally, especially in East Africa, the generation capacity of grids has grown faster than the demand, actually. So having more electricity demand, it can be a good thing. All these factors mean that we could expect to see EVs maybe being built, maybe being imported. Some of them may already be secondhand. So if we think about, what we may be getting, uh, there's a range. We may have hybrid electric vehicles. Some of them are plug-in, some of them are not. So these top two hybrid electric vehicles are essentially showing different drivetrain possibilities. But there's always a battery with a capacity that is not there for range, but it's there for efficiency and assistance, and it's still quite a big battery. Um, on the bottom kind of half of this quadrant of diagrams, you can see that how simple a battery EV is. Uh, Much better for maintenance. The battery is quite large, and usually it's just purely a battery driving an electric motor with some gearing. Uh, we don't expect to see too many fuel cells coming into the secondhand market since they're not really taking off in the primary markets. But in the end, uh, what is common across all these topologies, all these different items, is we have electric drivetrains, which other CEPREC folks have been working on. Our focus in this work package is thinking about the hybrid electric vehicles and the battery electric vehicles, whose batteries do degrade. In Rwanda, we have many hybrid electric vehicles whose battery has been turned off because it had a fault. So the stock of waste stream batteries is increasing. If we step back and think about our other choices for energy storage, there are always advances in chemistries. But for the next 5 to 10 years, we can expect the lithium ion to keep dominating. We might have lithium ion that's a ferrous phosphate. That's the most kind of common, safe type. There are other types of batteries too that are under development. And another thing to kind of watch for is the solid state batteries, which may make some more breakthroughs and become another waste stream. At the heart of it, the prospect of making a repurposing industry only changes a little bit when it comes to the battery chemistry. Of course, we have to be fully aware of the battery's characteristics, and the kind of downstream recycling issues are different for different chemistries. But when we think about that concept of can we repurpose the batteries of an EV, what we set up would be similar for these different chemistries, but we do have to keep an eye on them as we go along. One of the main drivers of how easy it will be to repurpose is actually the battery structure. So many EVs fall into these kind of two main categories. They may be composed of cylindrical cells. So if you look at the top left quadrant of this image, on the left, you can see a single cell. In the middle, you can see the module. And on the right, if you zoom back, we can see that the pack is made of modules. An electric battery pack is quite a dangerous object. It can be hundreds of volts at the terminals. And it can consist of thousands of cells. And we'll see later that these cells often, because of the management systems of the electric vehicle and the high standards that we have for transport, these battery packs are really high quality, even when they are coming to the end of their life. So the cylindrical cell is fairly easy to work with and repurpose. The prismatic cell sometimes requires compression to work. So it may come in the form of kind of a block like you see there. These are also pretty easy to work with. They usually have good mechanical connections. So that's that middle row. It's very similar. The pouch cell has a lot of cost advantages, but it's often harder to work with in terms of attaching to reliably. You can see the pouch just has these little tabs, and a module with pouch cells still has the same basic topology. Cells go into a module makes a pack. Of course, in the BYD, we also have the blade battery, which is a kind of I would say it's kind of a combination between the prismatic and the pouch type. But each one of these presents challenges in terms of reliably connecting these together. If you imagine how you're going to get to these cells, if you really are starting with an electric battery pack, you have the challenge that everything is in this sealed container. There's a lot of dangerous voltages inside. You require an awareness of how to safely break down a battery pack like this to actually get to the point where you can access a module. And even breaking down the modules is not trivial. So the reason we see this happening is that the cycle life of lithium ion batteries is quite good. If you look at LFP, which is kind of that blue zone that's sort of squeezed like this, different chemistries have different advantages. But the primary thing driving EVs and mini grids is cost. So when we look at the LFP, the lithium ferrous phosphate, it has the lowest cost and the highest life cycle. So it's just a great combination for applications like EVs, but also for mini grids. So if we think about these different aspects, in a vehicle, we have a volume constraint, we have a weight constraint. This is something that's sort of decided for us already in the transport application. But if we talk about mini grids, we're a little bit more free. So if we have to use more second life cells to make the same capacity, the same kind of block of energy storage, it's less of a problem for us. So although in this graph you can see that the lithium ion chemistries are sort of more energy dense, they're more power dense. By the time we're repurposing them, what we find is that we're actually paralleling them, and that density is helpful, but it's also counteracted by the fact that the battery is at the end of its life and its capacity may not be as high. So we saw the lithium ion adoption happening quite quickly. E-mobility drove it quickly. Of course, laptops and cell phones also drove that chemistry. And so the easiest cells to repurpose are these cylindrical cells. And we've seen that kind of take off initially as the first repurposing pool. So if you think about where lead acid batteries are now, they tend to be in the $100 per kilowatt hour range. This cost keeps coming down for lithium ions. And if we can repurpose them, we're again talking about a fraction of that cost. But what that hides, of course, is the necessity of making a safe system, a well-tracked system. But because of electric vehicles, this demand is expected to continue. So if we step back, there are a lot of bigger questions about the mining of lithium, the possible recycling at the true end of life of these batteries, and how can we make closed material loops for this technology. The repurposing is part of it, and the idea of physically changing the flows of these batteries is something that's still being explored. So what we can expect is that if we get these batteries, so we did an experiment at Carnegie Mellon taking apart a hybrid electric bus battery. And the paper indicated that there is kind of that 60 to 70% range of capacities. Of course, there's a distribution. Some cells are bad, some cells are quite good. In the end, there are a number of applications where we can expect additional years of life after our first use. And all of them tend to be in backup energy storage. So if we think about just building a storage system for a mini grid, that's one area. The thing to beat is the lifetime of batteries in normally mini grids might be like, say, 8 years. You have to have either the right business or the right quality product to sort of fit into that business model. It's also possible to use these systems for backup for charging stations, and even for grid support in terms of supporting the power system frequency. So typically we're kind of expecting to get at least a decade out of these batteries, based on what we know right now. But in a way, this is also a waste management solution. So being able to warehouse these batteries safely is already an issue. And maybe this isn't as bad as lead, but they're still pretty toxic components to lithium ion batteries. So when we see the possibility of repurposing, it seems like a great match. But the fact that people may be repurposing these batteries who did not design the batteries in the first place means that we need to have some standards, some sharing of experience to make sure that we actually can do these things safely. It's not expected the way batteries are designed right now to disassemble them, reassemble them, and reuse them with the same quality of safety. And in fact, some battery manufacturers have issued a statement, kind of an industry, saying no one should be repurposing batteries if they don't understand the characteristics, just to sort of cover themselves. So, in the end, if we're going to repurpose batteries, we need a way of assessing the state of health. If we're even going to handle batteries in these large quantities at the end of life, there's some additional safety precautions that we have to take. We have to have a well-equipped workspace that has the right PPE, fire suppression, and in the end, having procedures that we can follow to really efficiently assess these cells is a must. The other challenge that can come up if you're a waste facility is that there's many different types of e-waste, although they may break down in the end to cylindrical cells. The process you use to get there, depending on the product, is going to be specific to each waste stream. So as this emerges, we need to be sharing experience and keeping an eye on really not only the safety, but also assessments of the value of these batteries. What are they actually worth? How long can we expect them to last? How can we buy and sell them in a reliable way? So this is where we start to come to the business models. One approach that we can take this is essentially say, if you are the designer of a system with a battery, what you can do is have a plan to collect the batteries. You have a circular approach as the vendor. And in a way, this helps you keep control of the battery stock. Actually, the battery stock has a value, and we're increasingly starting to understand the value of used batteries. It's also a liability if you're a large OEM. So being able to control your risk, this is going to add to the cost of your operations, but it can be one of the simplest ways of doing this. If you're the expert in the battery system, you designed it, why don't you take the batteries back? So that's fairly compelling. However, even solar home system companies that repair their own batteries aren't really interested in capitalizing on the second life market. This isn't really seen as a kind of extra revenue stream for electric vehicle companies or even for solar home system companies. There are some companies that are starting to do this, usually because of compliance, I think. But to do this properly, it also requires quite a bit of engineering time and engineering competence and also labor costs. So you notice in Europe, they start to talk about robotic disassembly of cells. In Africa, we have a different labor cost structure. We have a great talent demographic. So the other approach to this is you say there are onward downstream uses for these batteries. And maybe we have a kind of collection system, partly state sponsored, where we can deliver cells to different places. We can assess their value, sell them through repurposing companies, and then we can create new products on the other side. So this is the concept of repurposing. What you can imagine is that this repurposing might just be an arc in a larger circle of eventually recovering the materials. So our own startup in Rwanda, Second Life Storage Energy, they have been delivering these systems for telecom towers, for microgrid backup. There are also examples of these batteries being used in charge stations by electric vehicle companies as a kind of demonstration. Like I mentioned, this could be part of an arc, and this is kind of the full dream that if we can participate in the waste stream, do some repurposing, but then actually recover the materials that we normally take out of the ground and make new batteries. This would be the true closed loop, the closed material loop that hopefully allows us to keep the costs low and keep the environmental degradation low. So this is going to need to start coming up even as we develop new sources of lithium. There are complexities to that. There are supply chain issues to that. So in East Africa, one of the dreams some people have is to actually say, okay, we have cobalt and nickel nearby. Why couldn't we be a hub for repurposing and even recycling and making new batteries? So and then creates new electrodes that are of the same quality or even better from the original batteries. So this is a possibility that people are looking at. Uh, if you look at the places where you can recycle a lithium ion battery, there are maybe one or two in the whole world. So even as these companies are increasing the number of vehicles they make, they also need to be thinking about the resilience of their supply chains and the cost of their supply chains. So there is a kind of interest in the industry for encouraging this. Uh, and that's sort of looking at the bigger picture of what can be going on in a circular economy. But how can it come to the case of a mini grid or a microgrid? One example that we have in Rwanda is the concept of having agricultural hubs that have a number of different energy services and also mechanized agriculture opportunities. So in Rwanda, Volkswagen has actually created a kind of e-tractor that can be leased by a co-op of farmers. And this battery system is integrated into their overall energy system where they have solar, and they also have sort of a general second life concept where as they start to move through batteries, they can have a cascade of these batteries to other uses. One of the other business cases we'll also touch on is SLS's business case, which is to work with one of the electric motorcycle companies in Rwanda. One of the challenges for this is that we're still building up the ability to work on high voltage packs to do diagnostics to see if we repair these things. So if we think about these different possibilities that are coming, we have streams of 2 and 3 wheel vehicles. SLS Energy has already shown in a partnership with Ampersand that they can make battery packs from the batteries of these EVs, these 2-wheel EVs. In CEPREC, we're kind of asking ourselves, every part of the vehicle, can we create a circular economy pathway for the batteries, for the power electronics, for the motors? In this work package, we've been specifically looking at the second life viability of lithium-ion batteries. We know that because the energy storage component is such a significant driver of the levelized cost of energy, when we can create job opportunities, create another market, and also make a domestic source of these batteries, this can be really valuable. One thing that's also worth mentioning in terms of business models is that rather than selling someone a battery, in this whole scheme here, you can be selling them not a battery, but energy storage, where you monitor the battery, you replace it whenever it needs a swap of its cells, so that the customer gets energy storage as a service, not just a product that they have to worry about. So there's innovation that's possible when we think about seeing these batteries as an asset and creating companies that manage their use as a service. Because of the waste issues, because of the disposal risks, it's worth leaning into whether or not we can create industries around these EV batteries. The volumes of EVs are slowly growing. We can get ahead of this. So we mentioned that there's a couple of different business models, depending on whether you're working with an electric vehicle company itself or a market where you have a lot of secondhand vehicles that are far from the OEM, or whether you're actually trying to look at the waste stream from a lot of different products. There are different business models that you can consider for each one of these cases. Power backup is just a huge market in Africa, whether you have a grid connection or whether you have a mini grid. So in the end, we have a number of use cases that we can be exploring for this, including the batteries as a service, including even doing something with the materials. So as we move into this, safety is key. That's why one of our team members is looking at that aspect of how can we share, develop protocols around the disassembling of high voltage battery packs. How can we also start to learn how to value these batteries? How can we provide testing procedures so that we can say what the lifetime of a collection of cells is going to be? So there's a lot of issues that have been opened up that are being looked into in Rwanda and Kenya. There's a lot of good work happening at Strathmore as well as at CMU Africa and KCRC. Really, this use case is being explored all around the world, including in China. So I think if we have the right collaboration, if we have the right pilots, we can really start to gain the confidence that we can make this repurposing safe, that we can make it profitable, and that we can solve a waste problem at the same time, leading us to this waste to watts concept. That's sort of just a glimpse into the repurposing area, the second life um, concept, also as it applies to mini grids. That's that's the main content of the slides that I had prepared. Um, I'd be happy to take questions or go back and clarify any issues that people may spot from my presentation. But thank you for your attention.
Thank you very much, Barry. Very insightful presentation. So now the floor is open for questions. You could please use the raise hand function, and I'll unmute you. So questions, comments, clarifications. You want to type it in the chat or raise your hand. So we have Boyega. So I'm going to okay, Boyega, I think you can unmute yourself now.
Yes, good afternoon, Professor. Good afternoon. Thank you for the lecture. So I'm in Nigeria. I just concluded my master's in energy studies, but receiving your lecture, I realized a lot of the use cases and the framing seem to fit the East African environment more because Uganda, Kenya, they seem to be making a lot more progress in my assessment with adoption of electric vehicles. Nigeria is still at the very early stages of adoption. I believe most people charge their vehicles at home. So for Nigeria, that is pretty much still at an earlier stage of EV adoption, what should be the focus for a charging station, for instance? If a charging station has yet to establish a system in the first place of charging, is it not too early to jump into second life attempt with batteries to use for an EV station? So my question would be, what would you say is the area that Nigerian enthusiasts like me should look at? Is it policy? Is it training to learn about battery safety, battery repurposing, and things like that? So what would be your assessment?
Okay, you have a lot of exciting opportunities in Nigeria. We know that the centralized power grid is limited in its ability to deliver megawatt hours. Of course, a lot of systems, a lot of businesses are just running on diesel. If I were in that context, if you were, for example, in Lagos, it would still be worth looking at the electric vehicle companies that are running two-wheelers there in Lagos, because they are already going to, I mean, the thing that you always have in Nigeria as an advantage is scale. So when things do take off, they become really big. What I understand is that if you were to broaden things a little bit and consider also looking at solar home systems as a source of cells, you may find that in Nigeria, there's already a pretty big stock of small battery systems that have been in solar lanterns, in small solar home systems that are essentially the same concept, the same opportunity as the EV waste stream. It's interesting in Nigeria because power is such an issue. There are probably quite a few potentials for vehicle to grid applications where someone works in an industrial place. Maybe they can get reliable charging from captive power by charging it at their office, at their work, and then they bring their car home and they can kind of plug their house into their car if the grid isn't working. So there's different use cases that will probably emerge in Nigeria that could surprise us. I think you're right that the prospects for that scaling of EVs is harder unless you have a combined charge infrastructure plan. So if we think about leveraging solar in business parks to actually charge the vehicles, probably the most promising thing you could do is start with fleets that are based on industries that already have captive power. So if you have a factory, they already make their own power. They may be looking for other ways to use their power, for example. So I would say the use cases are different. You could also just be looking at other cylindrical cell repurposing plays. And at the moment, what I understand is there are already solar home system companies that are importing EV batteries from China into Lagos. So if you want to kind of get involved, what you may do is approach some of the solar companies like Arnergy, like other even mini grid companies who are trying to source these batteries and find a way to learn how to work on battery management systems, how to maybe partner with solar home system companies who are trying to use these batteries right now as sort of a first use. I don't know if that's is that helpful?
Oh, yes, very helpful. Thank you very much. Of course, it broadens it more into the SHS area and the factories that have extra power to dissipate. So it's the broader perspective. So I appreciate that. Thanks.
Sure, no problem.
Thank you. And next will be Abiola Aino. You can unmute yourself now.
Good afternoon, sir. So my name is Aino, a PhD student from University of Lagos. So I want to ask, it is always advisable for the battery manufacturers that a battery, you should not open it, you should not expose it to them. When it is damaged, it is better you dispose it. Now we are now talking of second life of it. So are we not going against the precaution of the manufacturer? That's my question, sir.
You are. That's why we need to have. So there are two questions here. The manufacturers are taking that stance and protecting themselves by pointing out, okay, this is a dangerous activity. So one risk that we see is there are informal repurposing of battery packs that start. It takes a certain level of care and knowledge as well to safely disassemble a battery pack. So this is a kind of hazardous waste situation. You need to have the appropriate knowledge, the appropriate personal protective equipment. And you also are automatically going to still have battery waste. If you take apart a battery, you will have battery waste in the form of the cells that are not repurposable. You'll be able to tell that they're damaged physically. So the manufacturers have a responsibility for safety up to the end of life, and maybe including recycling. It's absolutely essential to have the right processes around this repurposing to make sure that any cells that are repurposed are actually safe physically. And for each waste stream, the fraction that's going to be safe is going to differ. We also don't have very much field experience with using these batteries for, years and years. So in every case, the battery management system would still be doing the same job, but there's kind of a higher diligence that we need to essentially make a product that can still be safe. So it can be done when we incorporate the knowledge that comes from how to safely use the cells as the basic building block. But just getting to the cell is a dangerous prospect. It shouldn't be attempted without the right PPE, without the right knowledge, without fire suppression. There's a reason that this doesn't just automatically happen. However, what most investigators have found so far is that if you take that kind of careful approach, it is worth doing these two things. Number one, you're breaking down the battery for disposal. So at some point, unless we just let these battery packs pile up somewhere, which is hazardous, someone is going to have to do the work of breaking these things down. It can be more labor intensive to break it down in a way that the cells could still be used. It's true, it takes more effort. But when we follow the right safety procedures, we can have this opportunity. We're still learning about the actual second lifetime of cells. But so far, if you have the right kind of discarding and filtering processes and you're discerning in the cells you keep, it appears that we should be able to do this safely. But it's a hazardous endeavor. You're absolutely right.
Thank you. Akabwe?
Okay, thank you, Prof. Akabwe Ranga from CME Africa. I would like to ask if these second life batteries have an expiry date, or how do you plan to track that battery life?
This is a good point. There's a kind of data science and physical modeling element to this, where lithium-ion cells have a pretty there's a kind of a cycle lifetime. So if you look at how the capacity changes with cycling, there's a design lifetime, but as a chemical object, these things have a certain degradation, a certain rate of degradation. And sometimes there can be a knee towards the end where the battery drops off. So the question is, how can we know how to extrapolate the cycles we can take these batteries through? We can be a bit conservative, look at the initial manufactured capacity of the battery and look at what it is now and make kind of a guess about how far we are in the lifetime. But no two batteries are exactly. So there is quite a bit of work out there now understanding the degradation mechanisms inside batteries. Clearly, if we come back to the previous question, we don't really want a situation where we're riding the edge of the battery safety too closely. So ideally we would want to do a prediction, maybe have some analytics inside the battery module that would help us detect if there's a more rapid degradation happening, but basically try to predict and then replace these batteries before they go over the edge, before they have a problem. So this is a case where all of the battery repurposing companies need to be collecting data so that we can start to understand this better. But there are some basic physical principles we can use to predict the degradation of the cells. Helpful, Cowboy?
Yeah, that was helpful. Thank you.
Okay.
Thank you. Next is Ndapewa. Can you unmute yourself? Ndapewa Ingefikwa.
Good afternoon.
Afternoon.
I'm Ndapewa Ingefikwa from UNAM, University of Namibia. I would can you hear me?
Yes, I hear you.
Yes, I would like to ask, considering this second life battery, what is their environmental impact when we are considering them to be integrated in the mini grids in Africa, considering their life cycle emissions and them repurposing to energy?
So if we didn't repurpose, we would have a higher life cycle emissions if we just simply put these in a landfill. but it seems like that is not what's going to happen. In terms of environmental damage, we have a risk of environmental contamination whenever we're putting these batteries out into the field. If you have a responsible mini grid operator, then they will be foreseeing the replacement time of the batteries, and they'll have to have, even to keep the mini grid running, they'll be anticipating the failure of those batteries. But the big question comes, will these batteries go into the landfill? Or can we repurpose them? It seems to me that if we can make a viable repurposing industry, it's more likely that these batteries actually can be split into useful and not useful, into second life and then waste. And then if we have this kind of repurposing industry, we should be able to generate value for the mass fractions of the batteries. Right now, if you want to pay someone to recycle a lithium-ion battery, it's costly. It's possible, but there are very few places that actually do it. But from the research that we've seen, even from some of the products that are out there, it is possible to break the batteries down through another process and sell the raw materials into some markets. There's a black mass market that you could look into. You could look into the company Tyson in China that essentially sells these black mass machines, and will even help you find markets or off takers. So I would say that when we don't have repurposing and recycling industry, and when we don't have guidelines, there's just a huge looming problem in this battery waste. There's a possibility for these batteries contaminating the environment. The lithium ion may not be as bad as lead acid, but there's still significant issues. I think that if we look at the life cycle emissions, all of it cuts down the more times we can recycle these things. The second life batteries are still going to become waste. But you could argue that because we're monitoring them, we will have an incentive to collect them. There'll be more of an incentive to collect them if we can create black mass from the batteries and then sell those fractions. But the profitability of these things is going to be kind of less and less. However, it seems as though these things could break even. They could be viable. They just need support to be created. Does that address your question?
Partially, I'm okay with the answer.
Okay. Feel free to maybe follow up by email with CEPREC, and we could try to direct you towards some deeper resources about this. Thanks for the question. It's a serious one, and in fact, one of the whole reasons to get into repurposing is that massive tidal wave of a waste problem that's coming towards us. I see some questions in the chat. Should I just maybe address those?
Yes, please, you can address those ones, and then we'll give Victor and Kingsley something. But yeah, carry on.
Okay. So Morris was saying the do-it-yourself and open source aspects. It is really interesting how diligent and also how detailed some do-it-yourself people are. There's information out there that manufacturers don't want to give in terms of doing these projects. I think that the biggest challenge is always liability. You could have a well-meaning person with some good information, but then the people who then do something with that information, if we don't have standards, if we don't have some regulatory aspects, then they're just really serious safety issues with this. So if you think about funding for startups, this is risky. Coming up with partnerships to have a reliable stream of waste is also a challenge. So in terms of funding sources, you could look at, like if you're in Nigeria, you could look at the Shell Foundation. If we want to explore this, you may be able to find some partnerships with vehicle OEMs. But so far, the funding for this has been coming from energy access space, coming from some large renewable energy calls. In Europe, there are some sources of funding to look at this as a waste issue, but they don't really tackle the kind of special context that we have in Africa, which is why CEPREC is so exciting as a project. So yeah, it's tough to look at the sources of funding for this, but the first place to start is the business case, and in the end, you can find a situation that that has incentives for all parties, and you're going to have an easier time figuring that out. The next question we had is do you have to have large volumes? Yes. Typically, the business case for this becomes a lot stronger once you have a large volume of waste to work with.
Okay. Yeah, we're almost out of time, so I just give Kingsley the floor now to ask the last question, and we'll wrap up.
Yeah. Thank you very much, sir. Thank you, Prof, for the section. So my question is still around the business scenario, business model. So I'm thinking, how do we balance affordability with long-term reliability and also liability when it comes to producing this, and who guarantees maybe the performance, and how do we structure the ownership? Either the warranty, what are the service model, in a way that will protect both the provider, we repurposing it, and the end users. I think that's my question. I don't know if you get that.
Yeah, I think you were saying, I think you're kind of saying, look, we want to get this in the market. If we rush it, there could be accidents, there could be fires. If we slow it down too much with regulation, we could face challenges. We could face kind of a slowing down, which means this doesn't really take off. Are those kind of the two? Is that sort of the tension that you're thinking about, Kingsley?
So what I'm looking at both the adoption in terms of how affordable it is to comparing to how long it's going to last, and the liability that comes with it when this thing is ready. So who guarantees the performance, and how can we structure the ownership, who owns it, the warranty, the service model around it, and in a way that will protect both us and also the end users.
So this is a good point. I think it's pretty essential that you use a service model the way Second Life Storage does, because just for the liability and also for the asset, if you acquire this waste and you put a lot of effort into figuring out the good parts of the waste that you can reuse, you probably want to maintain control of that, not just send the battery out into the world as a product. What it means is that we also have control a little bit over the lifetime. So if I want to make a module from Second Life cells and I maintain it, if I access it, I can maintain it indefinitely by swapping the cells out if I have the right technology. So in terms of lifetime, I think it makes sense to just switch to a service model where the lifetime is what the customer wants, and you maintain that. I think it's also possible to make products of different life. If you want a low cost, short lifetime. If you want a higher cost, long lifetime. These are all possible. But I think that it's really important that the repurposing company takes responsibility. And in most cases that they use a service model instead of a product model for this repurposing.
Thank you very much, Barry. Yeah, so we've come to the end of our webinar today. I just want to firstly thank Barry for this wonderful and insightful presentation, and to you all the attendees for taking the time for your contributions, and yeah, the questions is always very enlightening. Thank you. We have this monthly, but we'll have the next one in the first week of September, so 3rd of September. So if you're not following us on social media, please LinkedIn, search CEPREC, and then you can find all our events. Once again, thank you, and enjoy the rest of the week.
Thanks, Muwa. I'd like to thank my colleagues Yata, Rita, and Sarath for working together on this presentation.
Thank you.